So good morning, everyone who's in the US, I guess. Good afternoon for people elsewhere. My name is Jeff Rowe. I am the project or the program manager for LF Energy. And this is the 6th webinar in the LF Energy webinar series about the projects that are hosted underneath LF Energy. I'm going to go over a few slides in a few minutes, but first I wanted to go over the controls for the webinar. During the webinar, if you have any need to get in touch with me, you can use the chat window, which you can see in your controls, or you can raise your hand and I will reach out to you. There's a little button that says raise hand. And if you have any questions during the webinar, please feel free to post them to the Q&A box, which is another box that's down there along the controls. And if you have any questions, just reach out and get in touch. This webinar is being recorded. It will be posted most likely tomorrow on our YouTube channel, and there will be a link on the website. So hopefully that covers most people's questions, and we can go ahead and get started. As I said, my name is Jeff Rowe. I help run LF Energy. I'm very happy to do so. You want to move to the next slide real quick? Thank you. LF Energy started about a year ago as an idea that Shuli Goodman, our executive director, had. And one of the ways that she had this idea was by looking at this picture. What this is a diagram of the internet. And it's obviously zoomed out very far, but you can see there's a lot of different nodes and a lot of different types of connections between these nodes. And of course, one of the guiding principles of the internet as it was formed, it was to make it so that any time a node dropped out, it could be automatically routed around. So it was a very resilient, flexible system. And Shuli realized that we need to leverage these same design principles to scale our electrical grids and our electrical systems in the same way that we scaled the internet. And of course, the internet has taken decades to scale, and we don't expect all this to happen immediately, but it is happening right now. And the ways that it is happening is a very ripe market for collaboration. And of course, collaboration is exactly what open source software does best. Can you move to the next slide, please? So what LF Energy decided to do, or what Shuli decided to do, was approach the Linux Foundation in order to leverage the world's largest shared technology investment, which is the Linux Foundation. Linux Foundation is a nonprofit in the US. It hosts about 190 different software projects and umbrellas, including extremely large-scale projects like CNCF and the Linux kernel itself, all the way down to much smaller yet more very key technologies such as the Zephyr real-time operating system, the Yocto project for building embedded Linux, and a large number of other ones. You can see all of the projects that LF hosts at linuxfoundation.org. Next slide, please. So the mission of LF Energy in particular is to really promote open source as a method for driving the energy transition, to accelerate it by fostering and sustaining an ecosystem of vendor-neutral projects. And so far, there are 6 projects underneath LF Energy. We democratize state-of-the-art patterns to make these innovations accessible for everyone. And this is something that open source does across the board in a very large number of industries. In fact, there are pretty much no industries at this point that are not touched by open source in some way. Go to the next slide, please. We feel that open source really provides a safe and scalable environment to create code, and as well as some of the other things, artifacts that LF Energy is creating. Right now we have 3 software projects, but we also have 4 software projects. We also have an open data project and an open standards project. And these are all working towards developing these systems in a collaborative way. Most industries today run primarily on open source modules and APIs, and that's a very bold statement, but it is absolutely true. And one of the ways that I usually discuss it is to think of how many different computers there are. How many systems are there between myself talking to this microphone in California and you listening from wherever you are in the world? There are dozens of machines and systems in place, and a very large proportion of those are running open source, particularly in the telecommunications world. And that's just one simple example of where open source has really become the foundation and the backbone of the way that we do business. Next slide, please. These are the current projects underneath Linux Foundation Energy. We've designed this infographic so that you can kind of see how we picture the energy markets and the way that energy is produced and distributed. And this is it's a fairly standard distribution of categories. You can see under the energy markets, there's OpenEEmeter, which we'll be talking about today, and the methods that were created for OpenEEmeter, which were done under the Energy Market Methods Consortium, or EM2. These are all about flexibility and energy efficiency. Under transmission and distribution, we have some control room coordination software. Operator Fabric was contributed by RTE. Under planning, design, and simulation, Possible was also contributed by RTE, and there are existing webinars on those. We encourage you to go and look at them. ReApps is a very flexible edge protocol platform that was developed by Vanderbilt University, used for remote orchestration, distribution, and control, and especially is being developed in the scope of microgrids, which are both commercial and industrial and academic at this point. There are a number of universities around the world building out microgrids and simulations of microgrids. It's a very exciting place to be. We can see there are some gray areas that are very ripe for open source to help with, particularly in generation and renewable energy, and also in residential in terms of metering, energy storage, smart appliances. Cybersecurity is a very big deal, obviously, with the news this week, and the news, it seems like every week, there are always issues around security. And one of the misnomers about open source is that it's less secure, when actually open source tends to be much more secure than a lot of proprietary software, partly because of its transparency, and partly because it is also tightly, or it's strongly optimized for collaborative development. So there are many more eyes on the software. The sixth project we've got right now it's called OEDI. It's the Open Energy Data Initiative. It was contributed by the National Renewable Energy Labs in the US. It is a data lake, which is a very large amount, as in on the scale of 50 terabytes amount of energy data from sensors around the US that is being provided, and they're developing software to make it easy to aggregate and display that data in meaningful ways. So it's all very exciting stuff. We encourage you to get involved. Next slide, please. So these are the existing members of LF Energy. There are a number of other organizations that are in the process of joining. We really want to make sure to thank RTE and Faraday Grid. We want to thank Recurve for contributing OpenEEmeter and EM2, which we're going to talk about today. And all of these members are key to creating the energy transition of the future. So with that, I would like to turn it over to Phil to talk about OpenEEmeter and EE weather.
Perfect. Thanks, Jeffro. I apologize in advance. Hopefully this won't become an issue, but we've got a newborn in the house, and so and I'm at home, so if you hear any crying, I'll try to find a new room. But let's jump right in. Jeffro, thanks for that that intro, and I think it sets the stage well for jumping in and talking about the OpenEEmeter and EE weather. So I just wanted to really quickly kind of show you what we're going to cover in this webinar. In an introductory webinar, it's hard to, I think, cover maybe everything that you want to cover. And so there will be a little bit of room for Q&A at the end, but we'll be talking about what is it, why does it matter, how does it fit into LF Energy, although you may have a sense of that already, what is our process for developing it, making it work at scale, and how do you join if you want to participate, or if you're already using it, how do I contribute? So I'll jump right in. The OpenEEmeter. So first of all, we've got a link here to the documentation. This is a Python project, so you can install it using the pip tool for installing Python projects. But really, the code is not the core here. The code is, what does it do? Contains primarily the reference implementations of standard Caltrack methods. So if you're unfamiliar with that, I'll just give a really brief overview. Although, as Jeffro mentioned, we'll be going more into the energy market methods next week, of which Caltrack is one. The idea behind the OpenEEmeter, and EE, I assume if you're here, you know this, but EE stands for energy efficiency. And the OpenEEmeter is a way of capturing the code needed to calculate estimates of energy efficiency. So generally what that means is avoided energy usage. Prior to, so following an intervention, the OpenEEmeter will let you build a baseline model and use that to compare against what happened after or following an intervention, which gives you an estimate of the effectiveness of an energy efficiency project, or more broadly, really any sort of distributed energy resource, be that renewables or other behavioral interventions that manifest themselves behind the meter. And so the reason that this exists is because there really are many ways of making that calculation, and in some ways, many of them are right in different ways. And so the way in which the OpenEEmeter calculations and code try to be right are in transparency and replicability. So generally, how can you compute energy savings at scale? And in particular, do it in a way that's consistent enough to enable the possibility of markets that are built on top of those energy savings. And that's really a key thing that we're shooting for here. And so what that involves is standards compliance. It means very precise implementations of the methods as described. And in particular, sometimes methods can be a little bit fuzzy. And so having a reference implementation that's written in code can help clear up or expose any inconsistencies in the ways that the methods are written. And in addition, there are a lot of things that come up in real data that need to be addressed that sometimes aren't addressed in standards. Things like what do you do when there's missing data? How do you warn for detected scenarios? And the OpenEEmeter is designed to facilitate those things, so that even if you're coming with a data set that's incomplete, it will tell you the ways in which it's incomplete. And one of the ways that sort of manifests itself is in the modular design. So if there's a system that takes in that needs to perform these energy calculations, the OpenEEmeter wants to be able to fit within that existing external system, and so it's built into a system of smaller modules that can be put together in sort of just the right way under different circumstances. In addition, one of the core features of the CalTrack methods, and this is where the EEweather comes in, is that it's often helpful to build a model that uses external temperatures, and so we try to make that as flexible as possible. Generally, the CalTrack methods for computing the energy, the avoided energy use, suggest using public weather sources because that helps with replicability. So that by default is sort of what's available within the OpenEEmeter. And again, we try to build this on top of existing tools. So we're not reinventing the wheel here. We're really using SciPy, Pandas. If you're a Pythonista, you know these things. Particularly if you've worked in the scientific stack before. These are the standards for, or the de facto standards, I should say, for doing data analysis in Python. So that's why we build on top of them. So you can sort of take what you know and make it immediately helpful. And then again, further to the idea that the OpenEEmeter should provide transparent and consistent results, we include visualization and debugging, so that you can kind of go in, look at the data if you're using this for the first time, or if you're going in and trying to figure out what's, I've got two different calculations that should be returning the same answer and they're not. I go in and look at the visualization and the debugging that can help me find where there may be an implementation difference, or so those tools are embedded in the OpenEEmeter because they're frequently used. So moving to the next slide here, we've got just a quick, what is EEweather? It's a way of getting weather data from public data sources. It's also a way of matching to a weather station. So if you've got a building with a meter in a particular location, how do you determine what is the most appropriate weather station to match to? If there are 3 or 4 in the vicinity, it will help you to find a weather station that's in the same climate zone or that has high enough quality data. Originally, this package was embedded in the other package, but we found over time that there was enough complexity there that we pulled it out so that its dependencies are managed separately. So that's also available, and that's part of the OpenEEmeter project. Separate documentation here, also hosted by at the openee.io address. So why does this matter? And we've already got into this a little bit, but the idea is to have a weights and measures for computing avoided energy use. So that's a way of saying, this is a standard that we can compare against, and of course no no particular way of measuring is going to be perfect, but nor is the one that's included in the OpenEEmeter. It has its failings, but it is very useful as a benchmark that's been vetted against hundreds of thousands of different examples, and it's important both to have that as kind of a way of checking numbers, but also as a way of providing necessary transparency. So who cares about this? And there are many people in the industry that could care about this. Private companies. So these are people who are either building or doing building energy efficiency projects, or planning for future projects, or trying to decide what sorts of energy efficiency projects are going to be effective in their using the OpenEEmeter way of determining impact. Utilities who are running energy efficiency programs, regulators who are interested in evaluating these programs. And I'm sure many others. But when you use the OpenEEmeter, and that other people are also using the OpenEEmeter, that sort of gives you confidence that what you're looking at is vetted. The OpenEEmeter is starting to get used in pay-for-performance programs, and that's one scenario in which the number you come up with really, really matters, because you're getting paid dollars and cents for that number. So Jeffro mentioned this briefly, but the OpenEEmeter sort of fits into LF Energy in that little market section. So there really is sort of a symbiosis here, where the energy market methods and Caltrac are determining the methods that go into the OpenEEmeter, but the OpenEEmeter itself is also an important part of that process, providing reference implementation, facilitating methods. So not only does the OpenEEmeter have an implementation of the methods, but those implementations are a little bit flexible. They allow for testing. We've packaged a set of metrics, R squared, CVR, MSE, things that you can use to test different models and methods on different data sets. And it's important to have that within the OpenEEmeter so that the Caltrac testing can go more smoothly. And then again, there's another component which sometimes isn't addressed, which is that the ease of implementation and the maintainability of a particular set of methods actually does matter, especially when you've got many people using those methods or building on top of them. And so the OpenEEmeter is a way of determining whether the methods that are agreed upon are easy enough to implement. So if you've got a really complex method that's slightly better, may not be worth that cost. And that back and forth is something that the OpenEEmeter is meant to facilitate. So what's in scope and what's out of scope? The OpenEEmeter could be many things. What it certainly is are those tools and consistent APIs for quantifying avoided energy use or changes in energy consumption. And we really want that to be usable. So anything that goes along with that, tests, automated testing, the visualization and debugging, upgrades when those methods are modified, versioning that allows picking out a specific version of the methods that are changing over time. There are some things that are out of scope, so the OpenEEmeter is not an application. It's an embeddable library of code, so you're not going to necessarily have coming out of the box a way of scaling that to thousands, hundreds of thousands, millions of computations. And going along with that, since it's not an application, it's not storing state anywhere. It's really just a set of tools. And I think that's a limitation that helps it really focus on what it's good at, making those methods available, transparent, and not bogging them down in applications that, frankly, in most cases, would be better suited to embedding. Take the OpenEEmeter and put it into some existing system rather than building a system around the OpenEEmeter. Okay, so now we're getting into some of the details here. And I've got a few slides left. I want to make sure that we leave enough time for question and answers. I haven't been monitoring whether anybody's asked any questions as we've been going along. So forgive me if that's the case for you, but there will be a chance to ask questions at the end here. Okay, so how does the OpenEEmeter work? And again, before I jump into this, I just want to mention that there are some more tutorials and resources that I've referenced at the end of the slides. We won't have enough time maybe to really dive deep into the code, which I'd love to do, but the tutorials that I've linked certainly do that. But I'll give you just a really broad overview here. So if you're looking to try your hand at the OpenEEmeter, that you'll have a way to get started. So the Python package index contains the Python or the OpenEEmeter library. That's currently up to date. We're currently at EEmeter version 2.7.0, although that changes fairly frequently. We've locked those versions there so that you can upgrade when you want to. At your own pace, but that's open source. All the code is on GitHub, and that again is linked as well. So generally, the first thing that you might want to do if you're getting started with the OpenEEmeter is to run through one of those tutorials that I've mentioned, or to read through the documentation. The OpenEEmeter comes packaged with some helpful tools for complying with Caltrac. So, as I like to say, the OpenEEmeter is neither necessary nor sufficient for complying with the Caltrac methods, but it really can help. And those documentation help make it to help bridge the gap between the sufficiency gap there, where there are things that Caltrac or the methods, a full set of methods say that you have to do, of which OpenEEmeter can address 80%, but some of that needs to be written into the settings of code that uses the EEmeter, or built into code that processes data before it gets to the OpenEEmeter. And so we've tried to be as helpful as possible in that sense, because that's what people are using the OpenEEmeter for. It's for methods compliance generally. And as I mentioned briefly, the OpenEEmeter is built in Python. It is not, the methods, do not specify that the OpenEEmeter needs to be written in, or that the methods need to be done in Python. That's what we've built because that's what we find works for us. Not out of scope in the future, I think, to think about adding another language, but certainly certainly not in the immediate future. Okay, so how does it work? Generally, you're going to be loading in meter data and temperature data. Again, you can use the OpenEEmeter to obtain temperature data, but if you want, or you can use the samples that are supplied. But you load that data in, and then the primary task that the OpenEEmeter performs is to create a baseline model. So that generally involves some sort of a fairly simple linear regression that's based upon transformations of the meter and the temperature data. So that includes heating and cooling degree day transformations. There are lots of different ways of computing sets of heating and cooling degree days using the OpenEEmeter, using either hourly or kind of daily methods for doing that, using the average temperature or using hourly temperatures. It also has some toolkits for doing hourly analysis using hourly data. So that includes the LBNL time of week and temperature models that take into account the 168 hours of the week and build models based on usage during those times. It can do some grid search. So if you're checking multiple cooling and heating degree balance points, you can do that using the OpenEEmeter. And again, most of these methods are fairly flexible. So if you want to check different, sets of, do different grid searches over different sets of temperature data, or using different temperature data, or using different sets of balance points, those are possible. And so that all falls under the header of finding these baseline period models. And in fact, one part that's sort of overlooked sometimes is how do you actually determine what the baseline data is, especially when you're looking at utility billing data, which is supported within the OpenEEmeter. How do you determine, if you're looking for a year-long baseline, how do you slice up that data into something that looks like it's about a year long, when the billing periods have different lengths and different frequencies? How do you check that those models are good? We've got goodness of fit and other metrics that are built into the OpenEEmeter, some of which get automatically computed when those models are created, but others which can be computed at the time of making energy savings estimates, such as fractional savings uncertainty, which are part of the Caltrac methods, which give you a sense for not just a single meter, but if you've got a portfolio of projects, what are the variance on the savings as estimated by the baseline models and the observed reporting period data as when aggregated into a portfolio of a fairly large size. So those are available within the OpenEEmeter. And generally, the main thing that's happening is you're estimating differences in energy use before and after an intervention, using that baseline model. So again, people often can build on top of this. The OpenEEmeter out of the box doesn't have anything for, say, creating a comparison group of matched meters or similar buildings, but that's certainly possible to build on top of this. Um, and again, the OpenEEmeter is meant to be a little bit flexible to allow customization on top of that, in addition to implementing the standard methods. Okay, so really briefly here, I want to run through what it takes to get involved in the OpenEEmeter. Tentatively, we've scheduled bi-weekly public meetings, so these will be recorded and available if you want to watch them in, if this time doesn't work for you. But we've tentatively scheduled these for the first and third Wednesdays at 9 a.m. Pacific. Again, this may change, and that will be, if that changes, it will be available on the LF Energy site. I've linked to the mailing list at list.lfenergy.org, which is active. And that's associated with a wiki, which is not yet active, but which may be used for kind of taking some of this information about scheduling and or how to get started and resources. Those will be housed in that location or in the EEmeter docs. Generally, those meetings will address, coordination, planning, deciding what we'll be focusing our efforts on and addressing issues, although much of that will be contributor driven. So, as an open source project, we're really, the way that we do work is in response to what people need it for, need to use the OpenEEmeter for, and in particular, who has the resources to contribute to that. Generally, this is a project in which, a lot is possible, and the things that get implemented are going to be the things that are most important and solve the most pressing needs. And generally, that will be the flavor of those meetings, just sort of determining what resources we need to facilitate contributions of that nature. And just a plug here for our Europeans on the line, or elsewhere. We've got a lot of users in North America and the United States, Canada. We'd love to have people coming from other places, and we've tried to schedule the meetings early in the day, Pacific time, so that they can be late in the day, in the working day, if you're calling from Europe. So please, we'd love to have more participation. And if there are barriers to that, we want to know what they are. So make your voices heard. We would really appreciate that. And finally, I mentioned some links and resources. There is a tutorial that's built in a Jupyter notebook, which kind of runs through the basics of using the OpenEEmeter and EEweather together for, just runs through all the steps that you might go through to get things running, get your data in, build models, predict, use those models to estimate energy savings. And we've got a version of that, this Colab link here, that is an interactive notebook. So while this link to GitHub is not interactive, you can, of course, download it and run it on your machine. But if you want to just jump in with everything all installed and working, you can use this Colab link that'll allow you to play around a little bit without having to get a development environment set up, which we hope would facilitate that a little bit. And then again, try to make it as easy as possible to get up and running on these. So We've included kind of a basic Docker setup. If you've used Docker before, that will help kind of bootstrap the development environment for either using the OpenEEmeter, developing on it, or just kind of exploring. Some other, let's see, let me actually, oops, okay, just checking where we are here. So future development, what is coming in the future? We've got updates to the contract methods that are actively being worked on right now. So it's certainly on the roadmap to take those and incorporate them back into the OpenEEmeter, addressing any changes that have been made, making version updates so that we are tracking the compatibility at any particular time. We're going to be building in more warnings, more summaries, visualizations for the hourly method support that is a fairly recent addition to the OpenEEmeter. And if there are other standards that are useful, then we want to see if the OpenEEmeter can support those. Although we're looking for somebody to come along and sort of lead a development effort there if there's a desire for that. And of course, with any open source project, one of the great things is that you've got a lot of people using it, and that helps make it more bulletproof. So bugs are reported all the time, and we fix them as they come in, and try to make it as easy as possible to get fixes for contributions that have been previously made. So the method that we use here is anybody can contribute anything. Some open source projects require that if you've contributed something that you make a commitment to support that in terms of bug fixes. We've decided not to do that, although we do encourage that. Because we want to make it as easy as possible just to contribute something, even if it's a few lines of code or an update to the documentation. And again, that's how most people will get started first. It's by improving the docs, and so we really appreciate that sort of contribution. One of the investments that we've made in the past is in really thorough test coverage. So roughly 100% test coverage. That makes it so much easier to tell, if a change that you've made has broken other things. Again, that's a resource that's available for people who are contributing. There are tutorials, and then we've got a full set of API documentation that are available and linked in this presentation, which I believe will be made available. We've got a couple of resources here, links to resources, but I wanted to open this up now, open the floor to anybody who has questions, and I'll, Jeffrey, I don't know if you need a couple of minutes at the end to wrap this up, but if not, we'll jump right into the question and answers.
Yeah, any Q&A that people have, or any questions people have, please. If you raise your hand, I can enable you to speak, or if you want to type it into the question and answer box, we can do that as well. And we may or may not get questions. I know some webinars get a number of them, and some webinars don't get any. And you've covered this very thoroughly, so we may not have too many questions. Don't see any coming through, so I think we may be good.
Great. Yeah, if there are questions after this, sometimes you think of something right as the webinar is ending.
Mm-hmm.
feel free to reach out over the mailing list.
Yeah, that's a great place to ask questions because then it's also archived for other people to see.
Absolutely.
So, all right, well, let's, I think we can probably go ahead and wrap up and then take any questions to the mailing list. Thank you all for joining. The video and the slides will be up on the LF Energy website, as I said, probably by the end of the week. And we will see you again in about a week for discussion about EEmeter, or sorry, EM2, the basis for OpenEEmeter, or at least with Caltrack. So thank you all for joining.